morning, sir. My name is Go Sing Yi, and today I will present about the part of the introduction. Sir Francis Scotton have introduced about the idea of the regressions to the community in the examination about the relationship between the heights of the parents and the children. So what is the regression? Regression is the statistical tool used in the investing, financing, and the other discipline that attempts to determine the strength and the character of the relationship between one dependent variables and a series of the other variables, which is the independent variables. In the criminal report, y is represent the dependent variables and the x1 until the x6 is the independent variables. Y is the total overall reported crime rate per 1 million residents, and the examples of the independent variables is the percentage of the 18 to 24 years old in the college, and the percentage of the 25 plus 4 years, at least 4 years in the college.
Good morning, sir. My name is FATIN ATIQAH with NORDIN, and today I would like to talk about simple linear regressions, which is used to estimate the relationship between two quantitative variables. You can use SLR when you want to know how the strong relationship between two variables and the value of the dependent variable at a certain value of the dependent variable. Next is the simple linear regressions, allows you to determine the straight line which best describes the linear relationship, as a thread is drawn in the scatter plot. Last but not least is to determine the straight line linear regression, use the method. And last part is the assumptions of the simple linear regressions. First and foremost is homogeneity of variance, which is the sign of error in our prediction doesn't change significantly across the values of independent variable. And independence of observations is the observations in the dataset were collected using statistically valid sampling methods, and there is no hidden relationship among observations. Thank you.
Hello, my name is HANIHATIM ARIS. So I want to explain about MLR, which is to evaluate predictor for a continuously distributed outcome variable. So multiple linear regression is utilized when the approach computes coefficient for each independent variable, which is predictor, that best correspond with the sample observed data. So multiple variable regression allow us to first control for confounding. Each of the independent variable coefficient is adjusted for confounding by all other factors in the model. And the second one is make prediction. Model prediction might be interpreted as estimate mean for subject with a specific profile or as forecast for individual. And the third one is determine the relative significance of the independent variable in the model outcome. So interpretation for MLR is first to see if the total p-value suggests that this specific group of predictor is substantially linked with the result. And the third one is, if this is the case, the relative influence of individual factor adjusted for the other variable may be assessed using slope, coefficient interval for slope, and p-value for slope. And the last one is, what is the R-square multiple and how much variation does the model account for?
My name is GHIRITHARAN. In conclusion, based on the report, we can actually differentiate between two linears, which is SLR and MLR. SLR actually used to examine between dependent variables and also multiple. Meanwhile, MLR actually used to examine the relationship between dependent variables and also multiple dependent variables. Therefore, I would say that MLR is the best fitted model because one, MLR is the best regression choose for making graph and explanation, and also MLR is used for more complicated relationship requirements. Meanwhile, SLR is actually more used for easy captures. So that's all. Thank you.
The advantage of using multiple linear regression is it can determine the dependent variable based on multiple independent variables. Next, multiple linear regression also can determine how strong the relationship is between each variable. For example, we may be interested in knowing how a crop yield will change if rainfall increases or the temperature decreases. Multiple regression assumes there is not a strong relationship between each independent variable. It also assumes there is a correlation between each independent variable and the single dependent variable. Each of these relationships is weighted to ensure more impactful independent variables drive the dependent value by adding a unique regression coefficient to each independent variable. Furthermore, multiple linear regression is a more specific calculation than simple linear regression. For more complex relationships requiring more consideration, multiple linear regression is often better.